Mountains that refuse to stop. When most people look at mountains, they see something ancient, frozen in time, unchanging, eternal. But that idea is wrong. Some mountains on Earth are not finished forming. They are still rising, right now. And the fastest rising mountains on the planet are not in Europe, not in the Americas. They stretch across Asia. This is the Himalayas, home to the world's highest peaks, including Mount Everest. What makes the Himalayas special is not just their height, but the fact that they are still growing by millimeters every year, measured not by guesswork, but by satellites in space. So how can mountains grow? Why are the Himalayas rising faster than anywhere else on Earth? And what happens if they never stop? To answer that, we must go back to a collision that is still happening today. A continent on the move. Around 50 million years ago, something extraordinary happened. The Indian plate began drifting northward at a speed of several centimeters per year. That may sound slow, but on geological timescales, it is incredibly fast. Eventually, India slammed into Asia, but unlike an asteroid impact, neither continent stopped. Why the Himalayas exist at all. When two tectonic plates collide, one usually sinks beneath the other, but India was too thick, too buoyant. Instead of sinking, the crust crumpled, folded, and was pushed upward. That slow-motion collision created the Himalayas, layer by layer, mountain by mountain. And the collision never ended. Here's the key detail. India is still moving north, even today. GPS satellites show that India continues to push into Asia by several centimeters every year. That pressure has nowhere to go, so the mountains rise. This is why the Himalayas are the fastest rising mountains on Earth. How fast are the Himalayas growing? Thanks to modern technology, scientists can measure mountain growth with incredible precision. Using satellite-based GPS stations, researchers track vertical movement down to the millimeter. The numbers that shocked scientists. In many regions of the Himalayas, growth rate is 5 to 10 millimeters per year. Some zones rise even faster after earthquakes. That may not sound dramatic, but over 1,000 years, meters. 1 million years, kilometers. This is how giants are built. Earthquakes, sudden growth spurts. Most growth is slow, but sometimes the Himalayas rise suddenly. During major earthquakes, the crust can jump upward by several centimeters in seconds. Earthquakes are not just disasters, they are part of mountain construction. Everest is still rising. At the same time, erosion tries to tear it down. Rain, snow, ice, wind. The Himalayas exist in a constant tug-of-war between uplift and destruction. The paradox. Erosion makes mountains rise. Here's the most surprising part. Erosion doesn't just destroy mountains, it can make them grow. The weight removal effect. As glaciers and rivers carry rock away, they remove weight from the crust. The Earth responds by rebounding upward. This process is called isostatic uplift. It's similar to a boat rising when cargo is removed. So as ice melts and rivers carve deeper, the mountains push higher. Climate and tectonics are linked. In the Himalayas, heavy monsoon rains increase erosion. Melting glaciers remove mass, crust rebounds upward. Climate change can temporarily accelerate uplift, which means Earth's surface is reacting to both internal forces and atmospheric changes. Why the Himalayas matter to the whole planet. The Himalayas are not just mountains. They shape life across Asia. Climate control. They block cold winds from the north. They guide monsoon systems. They control rainfall patterns for billions of people. Water towers of Asia. Himalayan glaciers feed the Ganges, the Indus, and the Brahmaputra. These rivers sustain nearly half the world's population. What happens to the Himalayas does not stay in the Himalayas. A warning from the Earth. Rapid uplift also means more earthquakes, unstable slopes, and landslides. The same forces that build mountains also create risk. A planet still under construction. The Himalayas remind us of something profound. Earth is not finished. It is still shaping itself, still folding continents, still lifting stone into the sky. Every millimeter of growth is a heartbeat of the planet. And while humans measure time in years, mountains measure it in millions. The Himalayas will continue to rise, long after cities change, long after borders fade. They are proof that Earth is alive and still building.